Net ionic equations. Net ionic equations, we're going to show the ionic reactions that only have the ions involved. So we're going to reduce it down to only the species, the chemicals that are actually reacting. There are 3 steps in writing a net ionic equation. One of them is going to be balancing the overall equation to start with, writing the equation in ion form, so anything that's AQ you break apart into ions, crossing out these spectators. You remember from last time, and up here too, it also tells you spectator ions are present. They are sitting there, they are dissolved in water, but they are not doing any of the reacting. They are not breaking bonds or forming bonds. They do not take part or participate in the reaction. So we cross them out, and then we get our net ionic equation. So for example, this one's listed on your page there. This is sodium chloride and silver nitrate, and as you can see, the sodium and nitrate exist as ions on both sides of the equations. So they are the spectators, and that's why we cross them out here. Cross, 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 cross there. And now our net ionic ends up being silver chloride, formed from silver ion and chloride ion. So we're going to practice and do some of these now. And yes, on the test or quiz, you will be expected to write out the complete and then the net. And next year, if you decide to take AP, basically we end up, when we do our balancing and things, we always end up in the net ionic form because we care only about what is actually reacting. All right, so looking at this particular example, anything that says AQ, we need to break apart. Anything. Oh, this one, I don't have to break apart. Guess what? I can just bring it down. Cool. It's liquid. It's a pure substance. I don't have to do anything with that one. So I'm going to break apart the other ones into their ions. What I need to know in order to do that is their oxidation numbers. So hydrogen, what's hydrogen?
1 plus.
Plus here. Oh wait, first of all, are we, yes, it's balanced. It says it's balanced. We don't have to balance this one. All right, gotta make sure it's balanced first. So plus 1, bromine's minus 1. What's potassium? Plus, what's hydroxide? And we know this, we know that, oh, 2 pluses, they can't have 2 pluses. All right, and there we go. So we're gonna start breaking them apart. First one, H plus. Second one, Br minus. Third one, K plus. Fourth one, the hydroxide. Now this is all on the left side of your arrow. Okay, like so. Over here on the right side, once again, we bring down our water. It's a pure substance. If it's solid, liquid, or gas, you never break it up. You always leave it completed together. Here, we're going to bring down our K and our Br minus. Now, this is our complete ionic. We've broken everything up that needs to be an ion. Okay? Now, what we should locate are spectators. Which ones appear as ions on both sides of the equation? On the reactants and the products? Potassium's one, good, and the bromine, that bromide, actually, it's called bromide as an ion. So now we're going to do what with those? Cross them out. We're going to take them out of the equation, and we ultimately end up with H plus, OH minus, giving us liquid water. Now, these are ions, so they also get AQs. Anything in ion forms means it's dissolved in the solution in the water. And so this would be your net ionic here. Now let's do a couple more examples so you get the feel of this.
What's the difference between aqueous and aqueous solution?
Liquids are pure substances. They don't have anything dissolved in them. So like if we said it's H2O with the L next to it, it's all water molecules in there, nothing else.
It's like not like anything dissolved.
Nothing's dissolved in there, yes. Pure substance. All right, now next example. This one is not balanced, so we should balance it first. How do we balance this one?
Put a 3 next to C.
Put a 3 next to where?
CU, because you need to balance out the SO force.
All right, it's going to start here. Let's put a 3 here. Good.
And you have to put a 3 with the CF, with the CU, CL2.
Okay, then we have to put a 3 here. Good. Next.
Put a 2 on the FB, which also balances out the SLs, the CLs.
We put a 2 here. Is that what you're saying? All right. Are we balanced?
Yes.
All right. And which ones are we going to worry about breaking apart? Copper 2 sulfate, iron 3 chloride, copper 2 chloride. And the iron 3 sulfate we will leave together because it's an S. We don't break that one up. Now, I just want to go over something real quick about the way things dissolve. For example, if I have FeCl3 and it's going to dissolve in water, it's going to break apart into one Fe, but because there's this 3 here, that means it's also going to break apart into 3 chlorides like so. Does everybody get what I'm saying? So every time that little 1 formula unit breaks apart, we get 1 iron 3, we get 3 chlorides. Make sense? Because now we have more to deal with since we have a balanced equation and everything in it is not 1-to-1. Okay? So keep that in mind as to how we're going to put our numbers here for our coefficients. So, I'm breaking apart this one. I know the charge on the copper happens to be what? +2 because the sulfate is a -2. So let's break this apart. However, we do have to deal with this. There are 3 of them, so we would put 3Cu2+. And 3SO4 -2. Here, moving on to this next one, we have 2 Fe3 pluses plus, this is where it gets fun, because for every crystal we get 3, every formula unit we get 3 chlorides, but now with our balanced equation we have 2 of them, so it multiplies and gives you 6 chlorides. Does everybody see how I did that? The 2 times the 3 gives me 6 of the chlorides. Now over here on the products, this one right here, once again we get 3 Cu2 pluses. And what are we getting here? 2 of the chlorides, but multiplied by that 3 gives us 6 chlorides. And then our Fe2 SO4, 3 stays a solid. We don't touch that one because it is a pure substance, it stays together. Now I look for my spectators. Who's spectating? Copper and chloride, very good. Copper, chloride. Definitely both in ion form on either side of the arrow. Cross out, cross out. Now, when we're writing this technically, it doesn't really matter what way you do it, but we are supposed to write the cation first, so I'm going to write the cation first. 2Fe3 plus 3SO4 -2, and we get Fe2SO4 3 with your S. Then we finish it up by inserting our little AQs by our ions. Saves us a little time. We don't have to write it all through the complete. We just write it in the net at the end. Aqueous iron is just iron ions dissolved in water. And it usually makes a brown or like orangey color solution. Like copper forms, when it goes into solution, forms the blue color.
Is there a way to have a double displacement without having anything dissolved?
Without having anything dissolved? Probably not, because they would both just as solids fall to the bottom. All right, I want you to try this one on your own. Balance it first. We'll come back in just a minute, check your answer. Yes, we need to balance. So what do? We put a 2 here and a 2 here. All right, pay attention, please. Check your answers. Voices off. Let's go. All right, now we're going to take all the AQs and break them up. AQ, AQ, AQ. Leave the water alone. It's a pure substance, a liquid. So in this case, if this breaks apart, I have plus for the H, minus 2 for the sulfate. But there's 2 of them, so I need to write it as 2 H pluses plus 1 sulfate plus here 2 lithiums that are plus 1s because lithium's an alkali metal, so it's a plus 1, and 2 hydroxides. Hydroxide is still minus 1. We're going to go over here to the products now. Take a look. The water stays together, 2H2O. We're not going to change that. That stays together. Over here, we're going to break up the lithiums, 2 lithiums. Li plus, once again, alkali metal, plus your sulfate. Now you can tell what are the spectators. Who are the spectators? Lithium sulfate. We have lithium sulfate. So these guys cancel. What do we end up with? 2H plus plus 2OH minus, giving us 2 waters. Now, what's wrong with this? What would we do to this to make it correct? Everything, well, we do need to write an aqueous, you're right, over here. But what about these 2's? We need to have them in their most reduced ratio, so it should be 1, 1, and 1. Yes, we write net ionics in the lowest ratio possible. So, and if you can't already have seen the pattern here, any neutralizations, what are the net ionic reaction going to be? H plus OH gives you water. So if you haven't seen that pattern by now, after a couple of the neutralizations, you're going to see this happen in all of them. All right, this one is especially interesting because not only do we have liquid water, we also have carbon dioxide as a gas. So that's also a pure substance. So we don't touch these. These ones stay intact. They are pure substances. The only ones we're going to break apart are the AQs. Okay? Is this balanced? Do we need a balance? Where do we need a balance? HCl here. Where else? An ACl, is that it? Are we all balanced now? All right, now we can begin. Let's break them up. Sodium's charged plus 1, carbonate's minus 2, so we get 2 sodiums. We get 1 carbonate. We get 2 hydrogens. We get 2 chlorides. Now over here to the products. We get 2 sodiums. Na pluses, 2 of them, plus 2 chlorides. And we leave our water intact alone, H2O with the liquid. And we leave our carbon dioxide alone because it's a gas. Spectators. Figure them out. The Na and the Cl, so they cancel. Now what are we left with? Write the cation first. 2H plus CO3 minus 2. That's going to give us H2O liquid plus CO2 gas. And these, of course, are AQs. Everything balanced and in order? Yes? All right, last one. Let's take a look. We have aluminum sulfate plus sodium hydroxide, giving us aluminum hydroxide and sodium sulfate. And it's nicely what? Balanced. I don't have to do anything there. So, AQ, I'm just going to start breaking it up. What's aluminum's charge? Aluminum's what? Plus 3, sulfate minus 2. So let's go ahead. We need 2 aluminums at plus 3. We need 3 sulfates minus 2. Here, sodium's plus 1, hydroxide's minus 1. So we need 6 sodiums at plus 1. We need 6 hydroxides at minus 1. Over here to the other side. This one stays the same because it is a solid. We leave it alone. 2AlOH3s. And we break apart this last one over here. So we end up with 6 sodiums because 3 times the 2 here gives us 6, plus 3 sulfates. And our spectators happen to be sodium and sulfate. Cross them out, get rid of them. They don't participate in the reaction. Then we end up with 2Al3 plus, 6 hydroxide, giving us 2AlOH3s with a solid. These are AQs. And what else do we need to do here? Reduce.
Reduce them.
So the 2 becomes a 1, this becomes a
3,
and this becomes a
1.
There you go. Very good. So please finish the back. That's one of your tasks for next class.